Hello. We're looking at management system for smart drone traffic control. So we're talking about multi-purpose drones. So it is a comprehensive platform to manage, monitor, and coordinate the drone operations across like various sectors like delivery, surveillance, emergency response, and commercial applications. So there are several key components here. For example, drone fleet management, real-time tracking, scheduling, coordination of multiple drones operations with automated conflict resolution and optimal path planning. Then we have airspace management. So 3D airspace mapping with dynamic no-fly zones, weather integration, regulatory compliance monitoring. Then we have the communication hub, so centralized communication system for drone to ground, drone to drone, and integration with general air traffic control systems. Then we have the AI decision engine. This is the part we are most interested about. So machine learning algorithms could be deep learning algorithms for predictive analytics, autonomous decision making, and optimization of flight operations. So next, let's look at the system architecture. So presentation layer, we will have web dashboard, mobile apps, API gateway, real-time monitoring. And then we have application services layer, flight planning. So planning the drones to fly, their path and etc. Traffic management. Um, Several we are talking about a whole lot of drones sharing a common airspace. So this is important. Then we have weather integration, of course, emergency response, compliance checker, uh, analytics engine. Then we have core processing layer, AI/ML engine, path optimization, conflict resolution, real-time processing. Then we have data layer, time series database, geospatial database, configuration database, and as well as analytics database. Then we have the infrastructure layer, cloud platform, message queue, load balancer, security layer. So this is a typical traffic management flow would be like this: flight request, drone operator submits flight plan, validation, system validates its airspace and regulations. For example, compliance, which part of airspace could be is navigable, which is not. Um, AI processing, optimize path and check conflicts. Then finally comes the authorization to grant clearance and assign the corridor to fly. As well as we have this monitoring, always real-time tracking and adjustment. So key features will be safety first, advanced collision avoidance, emergency protocols and fail-safe mechanisms, real-time processing, so sub-second response times for critical decisions and dynamic adjustments, scalable architectures, so support thousands of corporate drone operations across multiple regions, analytics and insights, comprehensive reporting, performance metrics, and predictive analytics. Integration ready APIs for third-party systems, existing air traffic control, and Internet of Things device connectivity. Then we have this regulatory compliance once again, built-in compliance with FAA, EASA, and local aviation regulations. So looking at the technology stack, so in backend services as usual, we can use Node.js, JavaScript slash Python, the microservices with Docker, Kubernetes, or Redis, RabbitMQ. For AI and machine learning platform, there is TensorFlow, PyTorch, then Apache Spark, MLflow, and CUDA or GPU computing for hardware support. Then database systems, PostgreSQL, PostGIS, then MongoDB, InfluxDB, Apache Cassandra. Next come communication. So state of the art, the latest ones, or like 5G, LTE networks, LoRa, WAN, WebSocket, WebRTC, MQTT protocol. Then we can Cloud and DevOps tech stack could be AWS, Azure, GCP, then Terraform, then CI/CD pipelines and monitoring with Grafana, for example. Then security or Auth 2.0, JWT, then end-to-end encryption, certificate management, intrusion detection. So next, look at the core components. So airspace management engine, the purpose manages 3D airspace allocation and dynamic restrictions. The features will be real-time weather integration, of course, as always. Uh, Temporary flight restrictions, geofencing, altitude management, technology, PostGIS for spatial space-related queries, real-time weather APIs, ML for prediction, conflict detection and resolution. The purpose prevents collisions and manages traffic control. Features four-dimensional trajectory prediction, separation assurance, dynamic rerouting. The technology to be used for advanced algorithms, real-time processing, Monte Carlo simulation can be used, for example. Next, communication management. So this handles all drone system communications, features multi-protocol support, redundant channels, emergency communications. Technology can be used like 5G, LoRaWAN, satellite backup, WebSocket connections. Then we have this mission planning system. So purpose is optimizes flight paths and mission parameters. Features could be multi-objective optimization, fuel efficiency, time constraint, etc. Technology, genetic algorithms, S-star pathfinding, machine learning optimization. So let's take a look at the data architecture now. So real-time data pipeline, data ingestion coming from drone telemetry, weather and radar data, stream processing, Apache Kafka real-time analytics, ML processing, pattern recognition, predictions, data storage, time series, spatial analytics databases. Then we have this visualization, dashboards, alerts and reports. Alright, so that's it. So this is like an overview of drone management, smart drone traffic control management. We'll take a deeper look into different components that we are more interested in.